Hello everyone, I'm Sharanya PS, Assistant Professor, Department of ISC, AJIET Mangalore. In this video lecture, I will be discussing one of the lab program of the lab, C Programming Laboratory. Here, the question asked is to implement a recursive function for binary to decimal conversion. What is the main objective of the program? First, here we need to write a program which will convert a given binary number to corresponding decimal number. Second, we have to write the program using recursive function. The input for this program is a binary number. The output for the program will be a decimal number. With these prerequisites, let us understand what is the main concept regarding how to convert binary to decimal. That is, here the binary number is a base 2. It needs to be converted to decimal number, that is nothing but base 10. The normal logic that we use to convert here is, that is for any given binary number, we will be referring it as by its corresponding 2 to the power of 0 by multiplying. That is, if we refer to the number 1010, then its last number, that is unit place number, is 0. It will be multiplied by 2 to the power of 0. 0 is the last location, plus, and the next number is 1 into the next unit is 1. So 2 to the power of 1 plus 0 into 2 to the power of 2 plus 1 into 2 to the power of 3. And we will be adding all this. So it will be yielding the final result as 10. That is, in this particular location, we have the value normally referred as 8. And in this particular location, it is 2. 8 plus 2 is nothing but 10. This is a simple way of understanding this conversion. Now, if we generalize this is a decimal conversion, d of n into 2 to the power of n. That is, for any given number, we will be dividing it into each unit. That is, each number will be referred, and then it will be multiplied by 2 to the power, and then it will be added. This is a normal logic what it will be used to convert any given binary number to obtain its corresponding decimal value. Here one more point is, whatever the number it is given, that is 1010, it will be considered as a complete one number. It is as a integer, not as an array. Rather, it will be considered as a complete whole number, and it is referred by using integer value. Now, if we take one more example, here it is 1010 is the number given. So, its corresponding decimal value. How we can convert? Starting from the last digit, it is a 0, and 0 into 2 to the power of 0, it will be multiplied. Then, the very next one digit is a 1, and 1 into 2 to the power of 1, and 0 into 2 to the power of 2, and 1 into 2 to the power of 3. So, all these values need to be added together, which will yield you the final decimal value of the given binary number. That is nothing but 10 in this particular case. Next, moving to the program, how we can write. Here, the function used is, the main question here is to convert a given binary number to corresponding decimal number. One more main condition or the requirement here is we should write the recursive function. So we will begin with the main. In the main, void main we have written, and since we are using the function, I have declared the function in the very beginning. That is int binary to decimal, and it takes n as an argument, and it started with the header file stdio.h. Next, inside the main, here I have used one variable n, which is used to take the binary number from the user. That is like 1010. That is the number which is entered by the user and it is stored in the variable n. And then one more variable called result, which is used to store the final result which is computed by this function binary to decimal. Next step is to call the function, that is binary to decimal, and for this function we have to pass the value whichever it is taken by the user. That is nothing but the binary number which is present in the variable n. So we are passing the parameter binary to decimal n, and the result will be stored in the variable result after computation. In the final printf statement, we are printing the number as well as its corresponding decimal value, that is %d in binary, that is this is in a binary format. Its corresponding decimal value will be printed. Now let us try to understand what is the major logic we can build to convert any given binary number to its corresponding decimal value. Before moving to the code, let us try to understand what is the one condition. That is, whenever we are writing the recursive function, two major steps we have to come across. First one, we have to write the termination condition. Second one, we have to write a recursive function call. What is that recursive function? Function which calls itself, we call it as a recursive function. In this case, the binary to decimal is a function. So, inside here, that same function will be called once again. Next, I will mention why we have used mod and division. As we discussed previously, this mod operation will be used to obtain the last digit, or in other terms, this mod will obtain the remainder value. That is, n for any given number, if we are getting the modulus with the 10, which will yield the last value or the remainder. The same way, if we divide that number by 10, it will get the remaining values. Let us take one example and we'll try to understand why we have written this recursive statement, how it is working. Next, first coming to the first user given value 1010. This is the value that is entered by the user and it is referred with the variable n. So, binary to decimal function will take the value n, that is 1010. Next, it checks whether n is double equal to 0. No, it contains the value 1010. So, it is moving to the else part. And what is present in the else part? We are first, initially, we have checking n mod 10. What is the purpose of this n mod 10? It will return the last digit. That is, last digit, if we refer here, is nothing but 0. Last digit will be obtained, or we can say it as a reminder. In this particular case, we will refer to the last digit, which will return the value as 0. And next, after that, we are calling the function once again. That is, we have to compute the remaining digits binary to decimal value. How we can do that? We can get the remaining digit by performing n divided by 10. That is, n is nothing but now 1010 divided by 10, which will obtain the value as 101. That is, this is when modulus operator is used to obtain the last digit, whereas this division operator is used to obtain the next digit. These are very important from the point of getting the processing the next steps. We have discussed the same logic when we were finding the value of a palindrome number. That is to check whether the given number is palindrome or not. The same logic has been applied. Similar to that, we are proceeding in this program as well. Next, here we have used binary to decimal 101 into 2. This 2 is nothing but very important because we are converting to the given base value. So we are multiplying whatever it is computed into 2. Now when we write binary to decimal 102, it is nothing but a recursive call. Once again it will be calling the function that is nothing but binary to decimal. So the value of n is nothing but now 101. So it checks whether 101 is equivalent to 0. No, the condition is false. And next comes to the else part and it performs the statement, executes the statement n mod 10. What is the value of n now? That is nothing but in this particular case is 101. That is 101 mod 10 will obtain the value 1. And now once again it calls binary to decimal with the n value is nothing but, here in this case n is nothing but 101 divided by 10 will yield the value as 10 and into 2. This is how the next step is obtained. Next, moving to the, once again here we could observe that there is once again a recursive function binary to decimal. So it is going to call this same binary to decimal function with the value 10. And next, moving to the next statement, here binary to decimal, that is 10 with the n value equal to 10. 10 is double equal to 0. Now condition is false. It moves to the else part and it checks 10 mod 10. It is nothing but 0 plus binary to decimal 10 divided by 10. It is nothing but 1. So it is now currently we have the value 1 into 2. Once again we could observe this is also a recursive function. So it once again calls the binary to decimal value function with the value 1. So it is going to call and what is the value of n mod 10? That is n is nothing but, now we have 1. 1 mod 10 is nothing but 1. Next, binary to decimal of 0. What is the n value currently? It is nothing but 1. So 1 is double equal to 0. No, condition is false and it goes to the else part and it computed now and it displayed as 1 plus binary to decimal, that is 1 divided by 10, that is nothing but 0 into 2. Now we could see we have reached to the termination state. That is nothing but we have currently the value is nothing but 0. That is we started from the first all the digits together and we started removing the each last digit and then we are considered each remaining digits binary to decimal value by performing the same operation and we started adding up all together. That is the logic what it is applied. Now with this 0 value it goes, n value is 0 now. N is double equal to 0. Yes, the condition is true. So it returns the value 0. Where it returns? It returns to the point from where it is called. That is nothing but from the previous location, the point or the function from where that is called. So it is going to return it to the function binary to decimal. The value 0 is written. And next, so here it is nothing but 1 plus 0 into 2. So it is nothing but, what is the value? It is returning 1. Next, moving to the next, the 1 is written from this particular statement. Next, binary to decimal, whatever it is computed, here what it computed is a 1. 1 into 2 is 2. 2 is returned from this to the previous iteration. That is 2 is returned. Next, in this particular case, 1 plus 2 into 2. That is 4 plus 1, 5. 5 is the value which is returned to the next step. So, here finally 0 plus binary to decimal of 101 is 5. 5 into 2 is 10. So, 10 is the value which is returned to the final binary to decimal function's final result. So, it's 1010 is returning the value as 10. This is the logic how it processes with the recursive statement n mod 10 plus binary to decimal n divided by 10 into 2. That is, here it takes n as an argument, and if at all n becomes a 0, then in that case it returns a 0. When n is greater than 0, it keep finding the binary to decimal conversion, performs the conversion. That is, first it obtains the last digit, that is which is here you could observe with this 1010, it separates the last digit 0, 1, 0, 1 with, and it finds the remaining numbers binary to decimal value. How it finds the remaining digit? That we could obtain by n divided by 10. That is why we have used n by 10. And this need to be multiplied by 2. Why? Because we are converting it into corresponding base 2. That is 2 to the power of 0, 2 to the power of 1. Like that, we need to keep multiplying in each unit. So, this 2 is very important for multiplying with the remaining whatever the value it is calculated. This is how we can convert the given number, that is binary number, to its corresponding decimal value. This is a function that we use. That is, since it returned the value, the return type of this function is integer, binary to decimal, and it takes the n variable. This is where it holds the binary number it is entered by the user and checks whether n is equivalent to 0. If so, it terminates with the value 0. Else, it keeps performing the recursive function call. Next, if we look into the algorithm of the same program, here with the step 1 we started and reading the n, and here we are calling the function binary to decimal, and the value whichever it is returned will be stored in the variable result, and we are finally printing the result. This is the stop of the main function. And inside the function binary to decimal, we have written all these steps. You can add step 1, step 2, step 3 like that. And coming to the flow chart of the program, here we have to write the two separate flow chart because we are working with the functions. Here, this is the flowchart for main, and this is the flowchart for converting binary to decimal recursive function. Next, coming here, reading the n value, and binary to decimal function is called, so we are representing it as a function. And here we are printing the result. Now, coming to the function binary to decimal with the value n, we check with the two conditions. Whether n is equivalent to 0, then it returns 0. If it is false, it need to compute this n mod 10 plus binary to decimal n by 10 into 2. This is once again a function. So, even we can represent this in the function representation as well. This is how we can convert the given program into equivalent binary, given binary value to its corresponding decimal value. Now we'll try to execute this program and observe what is the output and how it will be computed. The same program is referred starting with the header file, and this is a function definition or prototype, and the main function. Inside the main we have taking the binary number from the user, and function call is with the statement binary to decimal, the function is called. and we are printing the result. Inside the binary to decimal, if value is equal to 0, then we are terminating. If else, first we are trying to find the last digit, and then we are finding the remaining values, binary to decimal value, and it will be multiplied by 2, and the final result will be added together. In each step, it is nothing but a recursive call. If we run the code, it will be asking for the user to enter a binary number. If we look into the same example, 1010. So, it will compute the value and it will be displaying it as 10. If we look into some other example input, 1, 1, 1. This is the 1 input and it computes its corresponding 101 in binary is, this is the value, and 23 is a decimal. This is how the given binary value can be converted into its corresponding decimal value. This is the output what we get for this particular program. So we have implemented with the two objectives. One is we have used a recursive function and we have converted given binary number to its corresponding decimal value. Thank you for listening.